Type A is capable of infecting animals. Wild birds are known as the host. Type A is responsible for large epidemics. Type A is divided into subtypes based on proteins on the surface. These proteins include the hemagglutinin and the neuraminidase. Type B. Type B is found only in humans. It's most common in children 5 and under. Type B is not classified by subtypes and does not cause epidemics. Most commonly found in upper respiratory tract, spread through sneezing, coughing, and splurting. Type C. Type C is most commonly found in humans and kids. It's more mild than A and B. It does not cause large epidemics. It's spread through respiratory droplets.
The structure of influenza. The outer layer is made up of spike-like projections that represent the envelope glycoproteins, hemagglutinin, and neuraminidase. The blue projections represent the hemagglutinin. The red projections represent the neuraminidase. Another important feature is the virus's segmented genome. The genome contains 8 independent RNA strands. This allows the virus to be constantly changing. The constantly changing virus is why new immunizations have to be created to fight it. The RNA is packaged in the viral core and is surrounded by a lipid membrane. Some differences in the structure of the different strands are: Type A has 3 proteins in the membrane, HA, NA, and M2. Type B has 4 proteins in the membrane, HA, NA, NB, and BM2. The enveloped virions have hexagonal structures on the surface and form long cord-like structures as they bud from the cell.
Signs and symptoms of influenza. Can include all or any of these symptoms: fever and muscle aches, headache, lack of energy, dry cough and sore throat. The fever and body aches can last up to 5 days. Cough and decreased energy can last up to 2 or more weeks. Initial clinical diagnoses of influenza may be difficult due to the similarity of initial symptoms associated with other viruses. These viruses include Mycoplasma pneumoniae, adenovirus, respiratory syncytial virus, rhinovirus, parainfluenza viruses, and Legionella. Appropriate influenza treatments. The The appropriate treatment for influenza depends highly on proper timely diagnosis. Influenza may be misdiagnosed as a bacterial infection. However, if a bacterial infection is suspected along with influenza, antibiotic treatment should be prescribed because it is possible for a bacterial infection to arise as a complication of influenza. Diagnostic lab procedures. There are a number of different diagnostic lab procedures that can be used to help in the diagnosis of influenza. These include viral cell culture, rapid cell culture, immunofluorescence, direct or indirect antibody staining, singleplex and multiplex real-time and other RNA-based and other molecular assays, rapid influenza diagnostic tests. Preferred specimens for this test are nasal pharyngeal or nasal swabs and nasal wash or aspirate. Samples should be collected no later than 4 days after onset of illness. Rapid influenza diagnostic tests provide results within 15 minutes or less. Viral cultures provide results in 3 to 10 days. Most rapid influenza diagnostic tests that can be done in a physician's office are 50 to 70% sensitive to detecting the virus and greater than 90% specific. Therefore, false negative results are more common than false positive results.